Okay, this is our transformer calculations. Now the first thing we've got to remember is the full formula, which is voltage primary over voltage secondary equals number of turns primary over number of turns secondary equals current on the secondary over current on the primary. Now look at this formula and remember the voltage primary is always on the top, the voltage secondary is always on the bottom. Number of turns primary is always on the top, number of turns secondary is always on the bottom. But the current secondary is on the top and the current primary is on the bottom. Now which part of that formula we use depends on the question. If it just gives you a voltage in number of turns, we'll just use this first part, Vp over Vs equals Np over Ns. If it gives you a number of turns in current, we'll use the second part. So it depends on the question what we use. You probably not use all the full calculation at once, but depending on the question, you choose what to use. Now, in part A, it wants us to find the EMF on the secondary. So that's the same as the voltage on the secondary. So we're looking for Vs. So let's have a look at this calculation and we can see if it will work out what Vs is going to be. So we'll take the part we're working with, Vp over Vs equals Np over Ns. Now the first thing we want to do is get Vs on the top. So let's invert that. So all we'll do is turn them both upside down. What we'll do to one side, we'll do to the other. So if I invert Vp over Vs, I must do the same with Np over Ns. So the equation then becomes the second part here. Now, if I'm looking for Vs, I've got to get rid of Vp. So what I do then, I take the Vs over Vp. I'm going to times that side by Vp to get Vs by itself, and I do exactly the same on the other side. And now what I can do on this side, because I've got to divide Vp and it times Vp, I can cancel. So the equation then becomes voltage secondary, number of turns secondary, number of turns primary, times the voltage on the primary. Put in some numbers. So the numbers here from our question in part A was 300 turns on the secondary. On the primary we had 1,200 turns, and the voltage on the primary was 230 volts. Do the maths and you see the voltage on the secondary is 57.5 volts. Now part B, we want to find the number of turns secondary. So take out of the equation the part we need. So we'll start with Vp, because we're given voltage, Vs, and we've got Np and Ns. That's our starting point. But we've got to find this bit here, we've got to find Ns. So the first thing we'll do is, like before, we want Ns at the top, so we invert this side, we must invert that side. So it then becomes Vs over Vp equals Ns over Np. Now, to get Ns by itself, we've got to get rid of this Np. So the Np is a divide, so we'll times that by Np. So if I times this side by Np, I must times that side by Np. So then becomes Vs over Vp times Np equals Ns over Np times Np. So we've times both sides by Np. Now because I've got a divide and a times Np, I can cancel that. Then the equation becomes Ns equals Vs over Vp times Np. Put in some numbers. Ns equals, Vs is 100, Vp was 230, and Np was 1200. Do the maths, and the number turns on the secondary is 521.7 turns. Now to find volts per turn on the primary, for part C this is, volts per turn on the primary, then volts per turn on the secondary. All we'll do is we'll take the volts on the primary and divided by the number of turns on the primary. So Vp was 230, Np was 1200. So our answer for the volts per turn on the primary is 0.19 volts. And this is for part A. It says in the question for part A of the question. Now to find the voltage on the secondary, volts per turn on the secondary, we'll do the same thing. We'll take the voltage on the secondary and we'll divide by the number of turns on the secondary. Put in our numbers and we have 57.5 divided by 300 equals 0.19 volts on the secondary.